Just a short discussion of the histogram, the image histogram, some of the characteristics of histograms, and in particular the way that we might use histograms in image processing and in remote sensing. So we typically start with a histogram, which is also termed sometimes a frequency diagram. And the reason for that is in a histogram, this is not a normal Cartesian display where you have x and y coordinates. In a histogram, you have a horizontal axis that covers the range, the entire possible range of a distribution, all the possible values that some data set might take. On the horizontal axis, you cover that entire range. So for us, in an 8-bit image, that range is from 0 to 255. And then a frequency, and this would be a count by the values ranging from 0 to 255 of all the occurrences of that value. So these would be pixels, or numbers of pixels that would fall within a particular value on the 8-bit scale. So in the normal distribution, this is the distribution that all histograms are compared to, and does not normally occur, oddly enough. But we do actually see distributions that are relatively close to normal in remote sensing when we're looking at difference images that we've derived by subtracting one image from another image, particularly in change analysis. You'll see this later on. So you can also have bimodal distributions, and these are quite common in remote sensing, particularly where you have water and land, although it's unusual for them to both be the same size. Typically they're different sizes, but you may have a couple of different peaks in the distribution, and then this is a distribution that really doesn't occur very often, and this would be a very gray image, you might say, or I don't know, I guess it would be an odd image, but certainly nothing like this really occurs to my experience in remote sensing. More commonly, we see histograms that have a particular skew to them. In this instance, here you have a negative skew, skewing towards the low end of the range with a longer tail on that side, and here you have a positive skew, skewing toward the upper end of the range. And so, this shifts the position of the median and the mode. Also, we sometimes use standard deviations in making adjustments to data sets based on the histogram. And so it's useful to know the percentages of the total area of a distribution, or the total percentage of a distribution that falls within certain standard deviation ranges of the mean. And so in the normal distribution, approximately 2/3 of the entire distribution, or 2/3 of the entire image, if we're thinking about images here, falls within one standard deviation plus or minus of the mean. Two standard deviations, approximately 95%, falls within that range of the mean, and then 3 standard deviations, over 99%, typically in a normally distributed image, falls within 3 standard deviations of the mean. So these are somewhat useful when we start doing stretches. Now, stretching, this is something that we do pretty much on the fly in ArcGIS and in most remote sensing applications now. And so in stretching, what we're doing is we're trying to visually improve the interpretability of the image, and we do that by taking the raw range, or the given range of a particular image. This one ranging, you can see, from 4 to 104. This would be on an 8-bit scale, and we stretch that out to using a linear function. We stretch that out to 0 to 255, and what typically happens, you don't really see this here, but we actually open up spaces between adjacent values in the raw histogram and really move them apart one from the other, so that they're more easily discriminated when we visually interpret the image. Here's another similar image that is is being contrast stretched, is how we would term that, or we're stretching the contrast in order to make the image more easily interpretable. So this is an example. Here's a raw image of an area that we're all familiar with, and we apply, and this is in the ArcGIS dialog for this single channel image, we apply a linear stretch across the range of the image. You can see the raw value here in gray, and then you can see the new stretched value in pink on this diagram of a histogram, and you can see some of the statistics over here. And so here is the stretched image, and you can see it's higher contrast, maybe easier to interpret. This is a tool that we have to improve the interpretability or the visual utility of particular images.